Hey Tech Marvels, welcome back to the channel. I'm your host, and today we are diving deep into Amazon DynamoDB with a complete hands-on lab session. If you're new here, don't forget to hit that subscribe button and ring the notification bell because we are constantly dropping amazing AWS content that will level up your cloud skills. We are going to create a DynamoDB table from scratch. We are going to learn about partition keys. We are going to learn about sort keys, insert real data, and explore powerful query capabilities. By the end of this video, you will have practical experience with one of AWS's most popular NoSQL databases. Let me tell you why this matters. DynamoDB is used by companies like Netflix, Airbnb, and countless startups to handle millions of requests per second. So whether you're preparing for AWS certifications or building your next big project, this knowledge is absolutely crucial. All right, let's jump into AWS and get our hands dirty. Now, first things first, I am logged into my AWS Management Console, as you can see, and I need to make sure I am in the correct region. This is super important because DynamoDB tables are region specific. I'm going to click on the region selector in the top right corner and ensure I am in US East North Virginia, which is US East 1. As you can see, I am already in US East 1. Perfect. Now, let's navigate to DynamoDB. I will click on this search panel and type in DynamoDB. I'll click here on DynamoDB. It's the first on this list. Now, here we are in the DynamoDB dashboard. As you can see on the screen, we currently have items returned 0, which makes perfect sense because we have not created any tables yet. So what we are going to do now that we are here is to create our DynamoDB table. By going to the right section, we have Create Table. I'll click on it. By clicking on the Create Table, I've been routed to the table creation interface. This is where the magic happens. So pay close attention because understanding these concepts is crucial for working with DynamoDB. Let me fill out the table details. I'll start with table name. I will enter Tech Marvel, DynamoDB table. Make sure you type this exactly as I do because we will reference this throughout the lab. The next step will be partition key. This is super important. So what I'll do is enter company ID. And I need to select the data type here on the right. For the data type, I'll select number. Now, the partition key is like the main identifier that DynamoDB uses to distribute your data across multiple servers for scalability. So the next step will be sort key. I will enter name with the data type as string. The combination of partition key and sort key creates a composite primary key that uniquely identifies each item in our table. Think of it this way. If you're storing employee data for multiple companies, the company ID tells DynamoDB which company the record belongs to. And the name helps identify the specific person within that company. Okay, now all other settings I will leave as default for this lab. In production, you may want to configure things like billing mode, encryption, and tags. But for learning purposes, the defaults work perfectly. Now I'll click Create Table and we wait for AWS to work its magic. Excellent. That took a few seconds. Our table has been created successfully. Let me show you what we are looking at here. You can see this is active. Notice the green active status in this table column. The interface that we see shows our partition key is company ID and our sort key is name. Exactly what we configured. Let me click on Take Marvel DynamoDB. I can see several tabs here. Overview, indexes, monitor, global tables, backups, exports, permissions. We have exports and streams. For today's lab, we are primarily going to focus on the items, but it's good to know these other features exist for more advanced use cases. Notice that there is also information about point-in-time recovery, which is currently off. This is a backup feature that can protect your data, but it does come with additional charges. Now, the exciting part now that we're here is let's add some data. I'm going to click on Explore Table Items. Now I am in the items interface for our table, which is currently showing items returned 0 because our table is empty. Let's change that by clicking Create Item. Now here's the item creation interface. I need to fill in our required fields. I am entering 1 for company ID. Remember, this is a number type. For name, I am entering Lamar. This is our string type. Let me click Create Item to save this first record. As you can see, we've created this first record, which is Lamar. The company ID number is 1. Perfect. Now, let me add a few more records to make our testing more interesting. I'll add Kendrick, I'll add Becky, I'll add Chloe, and Drake. I'm going to add these one by one by clicking create item after each entry. So let me click on create item. Number 2, Kendrick. Create item. I'll go back down. Create item. Becky. Sorry. Number is 3. Name Becky. Create item. I go back down. Create item. Number 4. Name Chloe. Create item. Go back down. Create item. 5. Name is Drake. Yeah, I had to put Kendrick at the top for those that love hip hop and probably understand this. Anyway, it's just me. I love listening to Kendrick Lamar. You know, I think he's better than Drake. But anyway, it's not part of this lesson. Back to what we are learning today. Now look at our interface. It shows items returned 5, and we can see all our data is in a nice table format. Okay, we have company ID values 1 to 5 with corresponding names: Lamar, Kendrick, Becky, Chloe, and Drake. Now this is real data in a real DynamoDB table. Each row represents an item in our NoSQL database, and each column represents an attribute of that item. Now, the next step is querying data. Now, this is a really powerful part. Querying our data. When we are querying our data, DynamoDB gives us 2 main ways to retrieve data. We have scan and query operations. I can see the interface has 2 radio buttons: scan and query. Currently, query is not selected, scan is selected. So if you do this, then query is selected. And this is what we want. Let me explain the difference quickly. Scan reads every item in your table. It's like reading a book page by page. Then query is much more efficient. It directly finds items based on your partition key. For our test, I'm going to query for a specific record. Let me set up the query parameters. Now, to select a table or index, this is already set to table. My DynamoDB table, as you can see here. We will select attribute projection. This is set to all attributes, which means we will get back all the data for matching items. Now, for the key part, the query conditions. Okay. Company ID, which is the partition key. I am entering 4. And for the sort key, I'm setting it to equal to. You have all these other options: less than or equal to, less than, greater than, between, begins with. So let's set it to equal to. Then we will enter Chloe. Now this query will find the item where company ID equals 4 and name equals Chloe. Now this will demonstrate the power and precision of DynamoDB queries. Okay, so I will click run. As you can see, items returned 1, items scanned 1, efficiency 100%. Okay, then we have Chloe and 4. I want you to notice how fast that was. DynamoDB can perform these queries on tables with millions of items in milliseconds because it uses the partition key to know exactly where to look for the data. Okay. Now, for an advanced query testing, let me show you one other way that you can test. If I remove the sort key condition and just search for company ID and search for 2, I would get all items for that company. In our case, that's just Kendrick, you know. So let me remove this and run. As you can see, we have Kendrick, we have 2. If I just search the partition key and place in 3 and run, we will get Becky. If I do the same, put in 5 and run, I'll get Drake. Perfect. Now, if you try to use sort key operations, let's say instead of equal to, I could use other operations like begins with, if I wanted to find all names starting with, let's say C. If we go here, begins with, place in C. And then let's say we take this off. Let's see what will happen. Okay, they are still asking us for the partition key. So let's say for C, we put in, let's say 2, or let's say 4. Then we run. Okay, items returned 0. And then let's say 1, 0, and then 3, nothing, then 4. Okay, then if we use this option, sort descending, we have nothing, then let's say greater than. We run, get nothing. If we do take this out, greater than, then we have Chloe, which is 4. Let's say greater than or less than. Okay, less than 3. We have Becky. Okay. Now, what I'm going to now do is to proceed to the next step. Now, the key takeaways here is that you must always provide the partition key in your query. You can't query DynamoDB without it. This is by design for performance reasons. That's why you see when we try to query without partition key, we got nothing. Let's say I put in Chloe. Without this, I don't get anything. But if I say 3, here I get Becky. So if we have Chloe here, less than Chloe, we have, which is company here, partition ID, we have Becky. Let's try another option. Less than or equal to, we get Becky. Let's try 2. We have Kendrick. So those are all ways of running queries, query tests. Now, before we wrap up, let me share some real-world insights about what we just built. In real-world applications, you would use this approach to build e-commerce orders. For example, the partition key, which would be customer ID, sort key would be order date. Then for gaming leaderboards, the partition key would be game ID, the sort key would be player score. For user profiles in a mobile app, the partition key would be user ID, sort key would be profile type. Okay, now the best practices we followed in this lab is we chose meaningful partition keys that distribute data evenly. We used appropriate data types, which were number for IDs, string for names. Now we kept our queries efficient by always specifying the partition key. What we learned is DynamoDB is a managed NoSQL database. And by it being a managed NoSQL database, you should always remember that no servers to manage, especially on your side. It is serverless. The partition keys determine data distribution and are required for queries. The sort keys allow multiple items per partition and enable range queries. And the combination creates a unique identifier for each item. Now, one thing you should always do, especially after such a session, is clean up so that you can manage your costs. Now this is something important you should always do. After such a session, you would want to clean up resources to avoid unnecessary charges. Okay, and one way that you can do that is to delete our table. So I'll go back to table list on the left navigation pane. Okay, and I'll select TechMarvel. And here, if you click actions, you have this. But what I'll do is click on delete. Then here we have confirm to delete. Now the table has been deleted. You don't want to have a table active and then get billed for a resource that you're not utilizing. And one other thing I want you to know is that when you've made an election to build your database using DynamoDB, The pricing would be based on your read and write capacity. It would be based on your storage used, and optional features like backups and global tables. For a small table like ours with minimal usage, the cost would be very low, but it's good practice to clean up always when you're done experimenting, just like we did. Now, that's a wrap up of our DynamoDB hands-on lab. Let me quickly recap what we accomplished today. We created a DynamoDB table with a composite primary key. We inserted multiple items with different data types. We performed efficient queries using partition and sort keys. We understood the difference between scan and query operations. We learned real-world applications and best practices. Now, your next steps would be for you to try creating your own table with different attributes, experiment with different query patterns, explore other tabs we didn't cover today, and consider how you might use DynamoDB in your own projects. Okay. Now, if this video helped you understand DynamoDB better, please give it a thumbs up. It really helps the channel grow and reach more developers like you. Drop a comment below with what you would like to see next. Should we dive deeper into DynamoDB advanced features, explore other AWS databases, or maybe build a full application using what we have learned today? Again, don't forget to subscribe and hit that notification bell, because we are constantly publishing hands-on AWS content that will accelerate your cloud journey. Thanks for watching Tech Marvels, and I'll see you in the next one.